All right, so I am here today to help you with problems. Last night we did a review. It's based off of this packet, so if you want to watch that and go over it. Secondly, I have no idea why, but I have 4 equilibrium 2s. I only print one extra one out, so it means at least 3 people do not have an equilibrium 2, and no one's admitting it. So I'll just put them right there. Or those darn custodians keep sneaking in my room, making extra copies, and putting them back on my table. All right, Libby.
Okay.
Looks like you've been wanting to ask this for like 3 minutes.
Equilibrium to number 12.
Of course you asked that. So number 12. Let's talk about the setup. Unfortunately, the final equilibrium 2 yet. There's something wrong with the final answer. So if that.
It's so small, isn't it?
I got a negative.
I don't know. Yeah, it is. So let's talk about the setup. I think I botched the. There's good things to learn from it. I'm not trying to bail out on it, but let's talk about it. Okay. So it says the initial amounts are introduced in a 2-liter container. I have 4 moles in 2 liters, and I have 6 moles in 2 liters. All right, so I have 3 molar, I have 2 molar, probably 2.0. No, actually, that would be it. Gives me a K, which is so tiny. So right there, in essence, what kind of reaction, like, where is this going? Where is this reaction always going to end up? Reactants, right? It's so small that what we would say, like if you were in a lab or you're looking at these values, is that basically this is a one-way reaction, right? This is basically going to just create reactants, not products. Like that's just what's going to happen. That K is so tiny. But we have to still be in the world of everything's technically being produced. I'm only going to set this up. Something is wrong with this, and I understand that. So it's my fault. If someone needs to hear that, that's fine. But still, you should be able to answer these. So determine the equilibrium concentrations at equilibrium. That's redundant. Equilibrium concentrations. That means I need concentration. So FYI, like if you look at the previous 2 problems, 10 and 11, why there's an extra line there is that you could have done that whole problem with moles, and then at the end you've taken your moles and simply divided it by the molarity. Sorry, the volume, and then you get molarity for concentration. But if you know ultimately you need concentration anyway, to me, I'd rather get it into concentration right away. So to me, right now, all I want to do is get a setup started for you. I don't want a final answer that something's not working well with this. But there are some things we should be able to do. This, we should be able to assume that's a 0. Like automatically. Like you have to know that. You can't be like, you didn't tell us everything. That's not how that works. I told you what we have. That means that I don't have the other things. So what direction is this going to go regardless of the K? It's going to go to the left. Why do I ask that? It's about the change. So this is just good to review for today. Are we understanding that these would be my changes, right? The negatives and the positives, and what numbers I have with them, because they just correlate to my my coefficients, right? So I have 3 plus 2x, I have x, and I have 2 minus 2x. So I would plug this into an equilibrium expression now. Okay, so I have 2.4 times 10 to the negative 25th equals 2 minus 2x squared over 3 plus 2x squared plus x. Next chapter. Technically, this chapter we should be talking about it, but I have made an executive decision, which cannot be overruled, that I want to focus more on the overall approach and procedure right now, and we're going to worry about quadratic formula later. So technically, this I feel really good about. This has to be my initial amounts, and I know it gets confusing when you have 2 different values, but they're basically the same ballpark. My initial amounts and my K, they have to be at least 100 times greater apart from each other, and meaning that my initial amounts have to be 100 times greater than my K. If that's the case, then I will be okay. In this case, I am more than okay. The difference will be great, but the problem is there's definitely a flaw in this problem, because if you do this right now, the final answer, this is just exaggerated way too much. I will have an issue with my final numbers where I will actually have a negative number for one and then an insane amount for the other. I mean, absolutely insane value. So this is where I'd like you to get to. What can I assume? Let's talk about that. What can I assume that I can take out? Yes, anything associated only with the x's, please, not just anything that's added. Anything that, anything that is being added or subtracted. Now, if you're doing that and you ultimately cross out everything, including like every x, you better step back and go, okay, that's not right. Something's wrong. And that usually is then, hopefully we run into it today, or else I will show you. It's the one that we can square the top and the bottom. And we take the square root, and then you won't cross out everything. But we do not want to do the quadratic tomorrow. That's the goal. I haven't even shown you one. And I know some of you know how to do it and probably can do it. But if I'm not going to model one and show you how to do it in this context, then that's not going to be tested on yet. So that's as far as I want you to go right now, okay? So if you continue to go, you'll know why. You'll know why. You can't go any further. All right, what else? I want to do anything and everything. Equilibrium 2, lesson 17 of book, work, anything you want. It only goes as far, though, as you have questions on. So for today. Yeah.
Can we do 3B?
Sure. All right, 3B. Let me just write out the equation quickly. And they say they're all gases. Okay, that's kind of a big deal. And it says if you place some, it says COBr2 in a 5-liter flask and heat it to form COBr2, that's what happens first. If you want Br2 concentration of 0.05 molar at equilibrium, how many grams of COBr2 will you use in the beginning? Okay, good question. So what's going to happen once in a while, you're going to get to an icebox and be like, oh, he didn't teach us this. There's always going to be something that you run into that will just be a little different. Okay, so what the icebox does is it helps you organize. I still run into problems where like, oh my gosh, okay, yeah, I guess I got to do this with that. Place the things that you know and allow it to help you. So I'm going to do a really weird notation right now. So you might just want to wait because I'm going to change that. I put some, it said, COBr2 in a flask, okay? It said, if you want Br2 concentration of 0.05 at equilibrium, how many grams of COBr2 did you start with? So it's a weird kind of wording, but what it's actually stating, it doesn't sound like this is the statement, but it is. That's how much is going to be at equilibrium. So if you're not sure what I did, reread that second sentence of B. It says if you want Br2 concentration of 0.05 molar. So that's what I'm hoping for. So I can manipulate this. I can actually start with a certain amount and actually end with the exact amount I want. But I need to know how that all works. So what else do I know before I even start filling in like the rest of the icebox? What's amounts? Is there anything else? I know a couple more amounts yet. Anybody know? There's 2 more things I can fill in right now. Amounts. Yeah. Here? Yeah. And you're like, whoa, that's a leap. That's not that big of a leap. I started with some COBr2. That's it. If it doesn't tell you anything else, that's it. This actually now is a much easier problem. The problem is if you haven't come and gotten help or worked on it, this is something you have not seen before. So let me show you the things I do know and the things I don't know. So I know that these are plus x and these are minus x. Why? Because I started with 0 and I started with a certain amount of that. So it's going to go to the right. It's going to make the amounts that are 0. So I know that. This right here is awesome. The minute I get this, that tells me everything. That tells me x. If I can have an amount in the beginning and an amount at the end, awesome. So what this problem already is doing is going to help me fill out a lot of other things. So I know what x is. So right away, I'm going to fill that in. And I'm going to strip maybe a sig fig off there just for space right now. And now, what am I actually solving for? I'm solving for my question mark. So you can pick whatever you want. I'm just going to pick the letter Y as a different letter, because I can't put X. Don't ever use X again. So besides the middle part, unless if you're going to use something else. So what I actually have is this. Well, not that notation. So I actually have that. I'm actually trying to figure out what I start with in the beginning. So what do? When I have an equilibrium, when I have this right here, if they're all filled in, then usually I'm solving for a k, or I'm just saying those final answers. Otherwise, what I'm doing is solving for something that I don't know. Well, in this case, it's not actually the equilibrium amount. I'm solving for the y right there. So help me out. What, anybody get letter A? I need the k from that. Or does it actually, it just says it, doesn't it? 0.19, is that right? Isn't that k?
Yeah.
Okay, so k was 0.190. I forgot that it was already given. So here I go. I just now plug it in. It's nice, there's no coefficients, always check that. There's no fault, like if you want to write it like that, that's fine. If you want to write it like this right away, because next chapter we're going to have a lot that are automatically the same on one side versus the other. So if you want to square it right away, I'm okay with that. Like that's totally fine if you see that happening. So that's what I'm doing. Then I will get a y. I'm not going to finish that one for you. You can get the molarity, and then what you need, I will give you a hint on this. Please, strong suggestion. I'm going to pause until I know what I'm saying. Whatever your y is, that's your molarity. Always have it equal. Like personally for me, I put it into my molarity expression. I don't want that to be the downfall of me mixing up, multiplying, and dividing, and messing that up. That it's an easy relationship. And then the final question. This just unfortunately is an extra step. Once I get that, then I need to convert it to grams. So then I would take my moles, right, and then I'd have 1 mole on the bottom of the COBR2, and then I'd have how many grams that is. Okay. So it's different. It definitely is. That would be definitely deemed a much a more difficult problem because you're actually going backwards. So that's a great question. And I know some people have come in and asked that or other questions similar to it. What else? We're kind of finishing that one up.
Can you do lesson 17,
5. Probably 5. Oh, it's very similar to what we just did. So I'll just get you started, okay? Alright. First thing for me, if I'm ever given Ks, you got to be careful. This is also an exercise of understanding moles and molarity. So this is problem 5 on lesson 17. What it's saying is at equilibrium, I have 0.5 moles of Cl2. What it's wanting is how many moles, eerily similar but slightly different, do I have in the beginning? Okay? So here, what I would do, strong suggestion, is get this into molarity because you're going to have to plug this into a K expression. You have to, so do it right away. You only use, by the way, the numbers here and the expressions here to put in my K. So what can I all fill in? These have to be starting at 0. Again, this would be plus, this would be minus. Okay? So x looks like it's 0.1. So then you can go from there, make it equal to here. Honestly though, take whatever answer you get. Technically, this would require a quadratic. Technically. Because my original amounts are not 100 times more the difference of my k. But it's okay. Let's just make an assumption, and if we're not right on, understand that that's why we're not right on. The difference in the answer is too great, so we would not be able to assume. But I'm okay with that for today. And I know, just trust that it's going to be okay. Like right now, I want to make sure that we can put this. If we're not doing ice boxes at all, and you just oh yeah, it's going to be that, and it's y equals minus. This is work. I'm amazed. I might be repeating myself, but I've said this a couple times, but I know I said it, I think last night at the review as well. Like, I don't want to be talking about it the next day or next week and talking about how many people did not have any ice boxes drawn out because you just assumed you had it all organized. This is work. This is actually stoichiometry. No, it doesn't seem like it, but you're actually showing mole ratios and comparisons and changes and how things are altered and all that. So do your work on an ice box as much as you possibly can. Again, unfortunately, technically this is a quadratic, but cross things out that you can. Don't cross out things that are multiplied, but things that are subtracted, and you'll get there. So it's very similar to 3b, extremely similar at this point. Okay, what else? As people are ready, and I can at least start setting it up.
Can we see Grant Potter for a moment?
Sure.
Thank you.
By the way, your ACT. Did you finish filling it out too? Did you double check it? Did you guys double check them already?
Yeah. Did we have to like fill in all the blanks?
I don't know. You guys should have gone over it. Just double checked it all. I don't know. Maybe it's not.
Do you want me to ask?
What else?
Do you want me to?
Equation, equilibrium 2, lesson 17. Libby, what does Brooke want me to go over? 8 on what? Problem 8? Problem 8?
Yeah.
Okay, let's do it. That's a good one. Nice question, Libby. You get an automatic A. Brooke, I know. I'm just going to borrow you. Okay, number 8 is a great question. It's hard, but it's good. If you're understanding a lot of this, I think you're going to feel like you're heading in the right direction. So let me show you how this one works. Okay, just making some notes for myself. All right, number 8, if you're working on other stuff, I'd definitely be with me on this one. This is like exercise 4 in the packet as well. So what it does is it says, hey, at equilibrium, it is found that I have 0.3, 0.1, 0.2, and 0.6 of these. So I just wrote them above, over their respective amounts. And you're like, oh, why don't you just put that in E? Well, hold on, it started like that, and then it's saying, hey, I'm doing a bunch of stuff to it. So I'm not totally confident that that's in an icebox yet. So kind of show you how this works. And then it's saying how much H2O do I need to add to make H2 to be at 0.7. So I started at 0.6, I need more. So it wants to know how much of, it's like a multi-step problem. How much of H2 do I need to add? And in a weird way, how much of the molarity do I need to add? That doesn't sound right. Usually we say how many grams, how many moles do you need to add. To say how much molarity do you need to add, that's kind of a weird question. So whenever we're doing that, and we're having equilibrium expression, or values and other numbers, there usually is a k. But there's no k. And in exercise 4, it says this as well. So how am I able to determine a k in this problem? Anybody know? K is the relationships of products over the reactants at equilibrium. So what are all those numbers in red right now? They are at equilibrium. So I need to find my own k. So I plug them in. So maybe you were already asked to do the expression, but if not, it's not going to go out of its way to maybe tell you. That's the secret part of this step. That you were actually supposed to find K. So that looks like it's 0.12 over 0.4, 1.2 over 0.4. I think that's 4. I mean 0.3, I can't see. So it's 4, which is a weird kind of K, but that's okay. So now let me start filling this in. I want 0.7 at equilibrium of H2. Okay? I have 0.3, 0.2, 0.6, and then here's the problem. I don't know how much H2O, because the question is, how much H2O do I need to add to make this 0.7? How much of this do I need to add to make it that? So that's the connection here. So by doing this, I'm going to write this really small, but this is plus x, minus x, minus x. I'm confident in two ways. One, when you add something on the left, it's going to drive it to the right. Le Chatelier. But I'm also just thinking math. 0.6 plus blank equals 0.7. You're not going to subtract unless it's, well, you can subtract a negative, but that doesn't happen in chemistry. Hey, put a negative in that beaker. Yes, I got it. So I'm actually going to fill it in. I already know my x, so I might as well write it like that. So my x is 0.1. So now I have a relationship here. So I have 0.3, I have y minus 0.1, and I'm going to go through this whole problem because it's kind of unique. And I have 0.2. Okay? Notice I don't have a lot of other x's or y's, so it doesn't matter that my numbers and my k are really close together because it's not going to require a quadratic. Now last hour I butchered this just a little bit. I don't like to do algebra on the board. I like to do it on the paper in front of me, so it did not go very well. ACD?
Yeah.
What'd you forget?
The English thing. Or the last section.
Mr. Newbaum, back over that?
It was all three of us.
Yeah. No. None of you did that? Okay, so you got to distribute this stuff, and then you got to send it to the other side, right? So it's however you want to make this all work out. So I will write out some of this. So we're all feeling good, and I'm going to make sure that I'm doing this correctly, because I totally botched this last hour. Okay, and now I got to distribute that, right? And now you can move forward from that. So that's what I got. Getting a little complicated. And algebra was definitely something that is needed when we're doing some of this other stuff this semester in this class. Algebra is really important to be able to rearrange some things, and maybe you would have done that differently. We've learned in very different times now. But the problem is this is not the final answer, and I'm not trying to trick you and didn't create the packet or anything else like that, but what's the actual answer? I mean, if you read the question at the end and think about it for just a moment. It says how much, I'm paraphrasing probably, how much molarity needs to be added of H2O? That's how much I need total. So how much was needed to be added? So what's the final answer? It's not 0.1. I think it's so 0.26. 0. Yep. So you started with 0.1. You started with 0.1, right? So you need to add 0.26 molar. of your. Just that sounds weird in general. You don't have a. Oh, it's a gas. Thank gosh. Oh, God. I was very concerned. I'm like, that can't happen. That can't be molarity with a liquid. Okay, so that's technically the answer. But if you're understanding a lot of at least what I did there and just the setup, then you're getting ice boxes. I will say that's not easy. So if you're starting to understand some connections and things, you're getting there. I'm not trying to trick you tomorrow. I'm not. This chapter is all about just, can you get ice boxes? Are you starting to understand things? Are you understanding where you put things when it's being said? Do you understand when it's a zero? Do you understand when it's an equilibrium value? Do you understand when you are able to know the x versus when you don't know anything on the bottom and they all are adding and subtracting x's? Which we haven't done a problem like that yet. So, anybody else have any questions? We have a lot of time. But I want to make sure that I'm answering everybody's. And if you don't want to ask, Olivia will ask it for you. So you just whisper it to her. She'll ask it. Morgan, please ask any question. Number 2 on the test tomorrow. All right, so number 2 on the test tomorrow looks like an icebox. There you go. It is actually. Actually, wait. Hold on. On the test? Problem 2?
Yeah.
Okay. Oh. Yeah, you gotta look, I didn't look closely. All this is, I'll just do one of them. When in doubt, guys, if you're ever writing things out, and you don't have to do it like this, but you can also always, if you need to do an extra label, you put like a little subscript, like when we did pressures. Remember, like if I were a volume, like gas laws, like I did an N, and oh, that's of carbon dioxide, or I'm talking about a volume and it's of H2. Like if you're ever needing to put a little label, a lot of times it's nice you can just put it kind of down there. It's not always the case, but all this one is doing is making you realize. If you look, the differences are the states. So the first one has all gases, so you do them all. So I'm actually going to do the one at 0. I'll do the second one to kind of to show you. So the second one, what happened to the Br2? What state of matter is that now? It's a liquid, so that's not in there anymore. So now it just looks like this. So that's what it's asking for. So now it looks like this as an example. Okay, so each one, what you're doing, I believe, I don't have it in front of me all of a sudden now, is that each one I think loses, like what happens to the HBr at -100? Is it a solid?
Yeah.
Yeah. So as you're cooling it down, what's happening is those attractive forces are occurring and you're going from gases and it's becoming liquids or solids. Actually, at the -100, is the Br2 still a liquid? Or does it become solid?
It's a solid.
It turns into solid? What else? Maybe what else? Let's go to number 10 for a second. Or is it number 9 for you? It's number 9 for you. On equilibrium 2. Okay, this is what it says. And then it gives me a bunch of numbers on the bottom. What if I asked you, and if you have some space, which you all should, what I'd actually like to know is right now, what does the KP expression, so generic, general expression, by the way, I won't say that tomorrow. Please understand, if it just says provide the KP or the KC expression, that is a generic relationship. So, what does that look like? Can you do that on the side right now? Because it will be asked at some point during the test. And most people, I'll say about 50% of students get something off on this. And they shouldn't. And then I just want to do one problem below it. Is that right? Why did I forget I2? Okay, so I shouldn't have I2, right? So I did have a success there. That's good. Why is that wrong, though? Because it's a pressure. There is no argument. Oh, come on, I got the products and the reactants and the right spots. I did the coefficients. Come on. No, it's wrong. It's not the way it's done. That's the right way. If you're uncomfortable with that, that's okay. You know, if you feel like it's getting lost. So, letter A gives you some numbers. And I could try to trick you and say something about the solid I. It doesn't go in there. So, what it's asking, if it's not at equilibrium, decide which way the reaction will proceed. What am I doing? I got to know which way it goes. I'm doing Q. If you ever don't know, you need to do Q. If you ever don't know. Let me go backwards for one moment. What if this problem, I gave you all the values, and it wasn't at equilibrium? Well, if it's not at equilibrium, that's an initial amount. And I asked, what's it at equilibrium? But they're all there. There's no zero. You still would have to do Q, because you have to know which way it's going to go. So if you're ever given amounts and you find yourself saying, I don't know where it goes, or if I don't know it's at equilibrium, the minute you say that, and if you have values of everything that would go in your K expression, that's Q. So where is it going? Which way is it going? Which direction is it moving? So I just want to do one of these. So this is what you could do. I wrote it down wrong, I'm sorry. I'll fix it, but I don't think I did. I don't need parentheses, but I just chose to do so. So I get 8.1. So that's my value. What do I do with that? Well, there's a couple things you could do. This is my Q. Okay. My K is, thank you. So that is bigger. Now, just saying that is not enough. Because to me, that is about a memorization. And now you're just saying, I have this memorized. You need to be able to now, you have to say something. So here are always your three options. It shifts left or shifts towards the products, or sorry, reactants. Shifts right, shifts towards the products, or no shift. So one of those kinds of answers. So which way is the shift? Left, right, or no shift? Shifts left. And I hope, I don't know if you're doing it, but I envision my K is just as a number. Oh, my Q is larger. It needs to come back to the K. As long as you always remember that everything goes back to K because that is equilibrium, the reaction will always reach equilibrium. Always. Always try to reach equilibrium. So this will shift. Left. Okay. So don't do an arrow. Try not to model that today. Drawing an arrow doesn't really mean anything. It's just an arrow. So, what else? If we don't have, that's fine. I always find that once we're done, then you start having questions, and if it's for the greater good and everybody can kind of see and learn from it, that's better. Again, I went through all the problems that I wanted to last night as well, and the answers are on those. At the ending, I did 5 multiple choice problems, so you can look those up on the answers to that as well. I want you to see how that goes. Okay, I'm don't see why, like, this is good, you got some time to work if you need to. Is everybody done with their Le Chatelier lab?
What happens to the other things you're gonna use?
The paper's turning in.
Oh.
I just need you to submit a picture.
Oh.
Try to crop it, please. I don't want a really beautiful looking rainbow and like 2/3 of the picture is a desk and a wall. That's what happened right away. That's why I sent that. Somebody sent one and they had really nice samples, but most of the picture was the desk, like that they set it on. They set it over here, or the table, and it's like, well, that's great. Crop it. Almost everybody. I'm assuming you guys all are able to do that pretty quickly and efficiently. So.